In part 2 of lecture 6, we will discuss tracing LR0 parsing. As we prepare to trace our way through parsing an expression given the LR0 grammar that we have, it's important to keep in mind what the three parsing operations are. Shifting means that we will move a token together with a state onto the stack, using the goto portion of the parse table. Reduce n, where we pop the items that we have on the right sentential form from the stack, and then we push the non-terminal on the left-hand side of production n onto the stack, along with a state that we will get from the goto portion of the table. We will see this momentarily. Thirdly, we accept. We accept that the program has been completely and correctly parsed, and then we terminate execution. The first thing that we will do is place state 0 and the end of file marker on the stack. When this is the only thing remaining, that's how we know that we are finished. Now, state 0 together with the negative sign gives us a goto of state 5. That will go on the stack together with the token minus. The action for state 5 is shift. So we're going to prepare to shift on the stack a constant, in this case 27, together with the goto, and we find this looking at state 5 and the token constant, and this gives us state 5. The action for state 7 is reduced by production 8. F derives constant. We will pop constant along with state 7. We will then push F together with the goto of state 5 and F, which is state 11. The action for state 11 is reduced by production 5. T derives minus F. That means I'm going to pop the F and then afterwards pop the minus sign. States 11 and 5 respectively will also be popped in the process. What I will do is I will take a look at the goto for 0 and T, which is on the left-hand side of the production in question. That gives us the state 2, and that goes on top of the stack. The action, as we can see in the table, for state 2 is reduced by production 3. E derives T. There's only one item to pop from the right-hand side, T along with state 2. We will then push an E, which is from the left-hand side, together with the goto of state 0 and E. That will take us to state 1. The action in state 1 is shift. We move the plus sign onto the stack. At the same time, goto of state 1 and plus will take us to state 8. The action for state 8 is shift. We move the identifier onto the stack, along with goto of state 8 and identifier, which is state 6. The action for state 6 is reduce by production 7. Factor derives identifier. We pop the identifier together with state 6. We'll push F, the left-hand side of the production, together with the goto of state 8 and F, which is state 3. The action for state 3 is reduced by production 6. T derives F. We'll pop the F as well as state 3. We'll push T together with the goto of state 8 and T, which is state 10. The action for state 10 is reduced by production 2. E derives E plus T. So we will pop in turn T together with state 10, plus together with state 8, and E together with state 1. We will push in its place E along with the goto of state 0 and E, which is state 1. The action for state 1 is shift. We push the end of file marker together with the goto of state 1 and the end of file marker, which is state 12, onto the stack. What we find when we get to state 12 is that the action is accept. The only item on the stack, excluding the end of file markers before and after it, is E, which is the start symbol for our expression grammar. We have completely and correctly parsed the expression.